where does the mass of the burned fat go? In our first experiment, we used an open system. That was a problem because our inputs had more mass than our outputs. We think this is because one of our outputs was gas, and the gas escaped and its mass wasn't recorded. So this time, we're going to use a closed system that traps the gas, and we're hoping that the mass of the inputs and mass of the outputs will be the same. Let's see the same experiment. So as we're starting, the mass before the chemical reaction is 400.31 grams. So we can see the duck fat burning, burning, burning. Still the same mass. Wow, in the first experiment, it burned a lot longer. Why do you think that the duck fat burned so much shorter this time? It probably has something to do with one of the inputs being oxygen, and because the system is closed, no more oxygen can get in, so it had less oxygen to work with. Okay, let's look at the container. What do you notice about the container? Do you see any evidence that a gas was produced? You're probably noticing some condensation, which tells us that water vapor, or water in a gas form, was produced. So the mass before was 400.31, and the mass after was also 400.31. Did the mass increase, decrease, or stay the same? It stayed the same. So now we know that we are doing it right. The mass of the inputs is the same as the mass of the outputs. We know that we're creating energy and some kind of gas, but we still don't know what kind of gas we're creating. The law of conservation of mass says that the mass of the inputs and the mass of the outputs of a chemical reaction should be the same. Our data does support the law of conservation of mass because the mass stayed the same. This is because we used a closed system that captured the gases. Now we need to figure out what are the gases that are being produced as an output in this chemical reaction.